This is Chapter 9 of our AZ-204 journey. The focus is performance, scaling, and optimization. Applications must not only work, but also perform efficiently, scale under load, and minimize cost. Why is this important for the exam? Because many scenario questions will ask you to choose the right scaling strategy, caching approach, or performance optimization technique. Mini review. Performance equals responsiveness, scaling equals elasticity, optimization equals efficiency. What is scaling? It is the process of adjusting resources to handle workload changes. What are the two types of scaling? Vertical scaling, also called scale up, means using a larger resource. Horizontal scaling, also called scale out, means adding more instances. What is elasticity? The ability to automatically scale resources based on demand. Mini review. Scaling equals vertical for power, horizontal for numbers, elasticity for automation. How does app service scale? By adjusting the app service plan. What are scaling options? Manual scaling, auto-scaling based on CPU, memory, or schedule. What is the benefit of deployment slots in scaling? They enable seamless upgrades and testing in parallel. Mini review. App service scaling equals plan adjustments, auto-scaling, and slots. How do Azure functions scale? In the consumption plan, they scale automatically based on events. What is cold start? The delay when a function is triggered after being idle. Premium plan reduces cold start. What about dedicated plan? It provides predictable performance with reserved compute. Mini review. Functions scaling equals automatic in consumption, predictable in premium, dedicated in dedicated plan. Why use caching? To reduce repeated computation or database queries and improve response time. What options exist in Azure? Azure Cache for Redis in-memory caching, CDN for static assets. When to use Redis? For session storage, real-time leaderboards, fast lookups, or queue-like operations. When to use CDN? For static files such as images, scripts, or videos that must be delivered globally. Mini review. Caching equals Redis for data, CDN for static files, in-memory for quick app lookups. How to optimize SQL database? By indexing properly, avoiding table scans, partitioning large tables, and using red replicas. How to optimize Cosmos DB? By choosing a good partition key, provisioning throughput correctly, and minimizing cross-partition queries. What about cost optimization in databases? Use autoscale for Cosmos DB, adjust DTUs or vcores in SQL database. Mini review. Database optimization equals indexing, partitioning, throughput, and autoscale. How do you ensure performance? By monitoring telemetry from application insights and Azure Monitor. What metrics matter? Response time, error rate, CPU, memory, request rate, and throughput. What tools help? Log analytics queries, dashboards, and alerts to catch anomalies early. Mini review. Monitoring performance equals watching metrics, analyzing logs, and acting on alerts. Scenario 1. A web app slows down under heavy load. Solution. Scale out app service horizontally with auto-scaling rules. Scenario 2. A function suffers from cold starts. Solution. Use premium plan or pre-warmed instances. Scenario 3. A global website must serve images quickly. Solution. Use Azure CDN for static files. Scenario 4. Cosmos DB queries are slow. Solution. Redesign partition key and provision higher throughput. Scenario 5. SQL database costs are too high. Solution. Use elastic pools or adjust pricing tier. Mini review. Scenarios show scaling, caching, and optimization choices. Best practice 1. Always design for horizontal scaling, not just vertical. Best practice 2. Use auto-scaling to match demand and reduce cost. Best practice 3. Implement caching at multiple layers to reduce latency. Best practice 4. Optimize database queries and partitioning early. Best practice 5. Continuously monitor and tune resources. Mini review. Best practices equal horizontal scaling, autoscaling, caching, optimized queries, and monitoring. Review time. Performance, scaling, and optimization are tested indirectly in many exam scenarios. Scaling means vertical for bigger machines and horizontal for more machines. Elasticity means automatic scaling. App service scales by plan and auto-scaling rules. Functions scale automatically in consumption plan and predictably in premium. Caching uses Redis for data and CDN for static content. Database optimization uses indexing, partitioning, autoscaling, and correct throughput allocation. Monitoring ensures performance issues are detected early. Scenarios highlight correct choices like scaling app service, upgrading functions plan, using CDN, optimizing Cosmos DB, or adjusting SQL tiers. Best practices are to favor horizontal scaling, autoscale, cache aggressively, and monitor continuously. Final message: Azure solutions must be built for performance, scaling, and cost efficiency to succeed in production.